Hello, everybody. Our problem that we are solving is that people neglect their plants, watering it and doing it in a timely manner. So our project is to make a automated plant watering system that measures the moisture of the soil, the temperature, and the humidity, and regulates when your plants get water.
Hello, this is our demo video. Right here we have our LCD display, which displays humidity, soil moisture, and the temperature cycling through. And then here's our water level checker, which just looks in the inside of our fuel tank. Here is our humidity sensor and temperature sensor. The soil moisture sensor is in the bottom of the plant. And then this is our watering tube, which just comes out the top. It's connected to the water tank below, which is down here. And that waters the plant at a 30-minute interval when needed. And then this is how you refill the tank. And this just goes directly into the water tank, like so.
All right, now that we've filled it, we're just waiting for the sensor right there.
There you go.
Starts filling with water. It's gonna go for 5 seconds and then turn off.
10 seconds.
10 seconds and then turn off.
Yep.
There, turns
then
off.
It will take another soil reading in 30 minutes, and if it determines that the soil has not been thoroughly hydrated, it'll water again. All right, I'm gonna walk you through how our prototype works. It's a wall plug-in, so you just plug this in, nearest wall plug, and then you set this somewhere in range. This is where your plant would go, and plug this into the bottom to get soil readings. This sensor detects the air's moisture and temperature. On this LCD screen, all of those data values will be projected every 5 seconds after it's plugged in. This spout here delivers water to your plant periodically whenever it needs to be watered, and you can refill your plant here. This goes into a water tub below, and you can check the water level with this here. All right, I'm gonna walk you through our flow chart. This checks if soil moisture is above the value 350. That basically says, oh, the soil is dry. And if our state variable watering and state variable weight are false, just to make sure that the 30-minute wait period isn't being looked over and the plant is not already being watered. If these are the case, it'll turn the motor on, set the state variable watering to true, and set weight equal to true. And then this will check if watering is the case, and then it'll water the plant for 5 seconds. That is the water interval and the current millis. And then after that, which is 5 seconds, it'll turn the motor off and set watering equal to false. And then this here will wait until the wait time has been exceeded, which is 30 minutes or like 18 million milliseconds. Once that's the case, it will check the pin state and current time, and then reset the weight value and reset the timer. And then this will be acting concurrently with all this stuff. Basically just checks the time every 5 seconds. It'll switch the display state from 0 to 1 to 2 back to 0, cycling through humidity, temperature, and moisture. Over here's our code. This code here dictates the this code here will check whether will turn on and turn off the motor, as we just previously discussed with the flow chart. And then this down here will decide whether 30 minutes has passed and to check for another watering or soil moisture value. And then down here is the display state stuff, just LCD prints with the logic we just discussed, as well as this if statement here to check for any errors that our modules are giving us. And then over here we have our wiring diagram. The Arduino Uno is powered by a 9-volt battery or a wall power. For our demo day we used a 9-volt battery, but we hooked it up to a 12-volt battery so we can just plug it all into the wall. This DH sensor is powered by the Arduino, which is 5 volts. The LCD display is powered by the Arduino, uses pins 7, 8, 9, 10, and 11, and 12. 5 volts of power connected to the ground rail twice. Soil moisture sensor is connected to an analog pin and 5 volts of power, and the ground rail and the pump is connected to pin 3, the external power, which is 12 volts, and the ground rail through a 5-volt relay, mechanical relay.